Good evening, everyone. My name is Aya Yari, and I will be your host for today. Our guest speaker is Kanan. He is a data migration and integration expert. With 18 plus years of rich industry experience and in-depth knowledge, he has designed and delivered solutions for various complex migration, conversion, and integration projects for Fortune 500 companies. Please give a warm welcome to Kanan.
Hello, everyone. Thanks for joining with us today. In today's session, we are going to see the quick introduction to dataZap, and then overview of the terms like data ingestion, data integration, data migration. And then using dataZap, how we can build a data ingestion pipeline, and how to orchestrate a data integration, and creating data migration plan. So this is the agenda of this session. Let's get started. So a quick introduction to dataZap. So dataZap is a data integration and migration platform. So it is part of the Changes platform. It does all the data movement with low or no code approach, and it is hosted as an integration platform as a service. It's a multi-tenant cloud application. It can be also deployed as a hybrid cloud or on-premise model as well. And so it supports all type of integration environments between like cloud to cloud or cloud to on-premise, on-premise to on-premise, and on-premise to cloud. So all sorts of data integration and migrations are possible with the help of dataZap. And it supports near real-time integration and scales to meet all your high volume of ETL needs as well. And this is the architecture of dataZap components. So on the left, you can see all the endpoint types like relational databases, enterprise applications, and cloud applications, big data lakes, NoSQL databases. So all those of endpoint types are available. And then we have a endpoint connected to each of these endpoints. Okay. So basically, we use JDBC to connect to relational databases, and SAP JCO to connect the SAP systems, and the REST and SOAP APIs on OData APIs for connecting to the most cloud systems. Okay, and then we have a extract adapter, which is primarily used for extracting data from the source systems. Okay. So it has all the CDC engine filters and user input engines and crypto engine. Then we have a load adapter, which is primarily used for loading data into the target system. Okay. And it has many more components in it, not just loading. Okay. So it helps to validate your data and transform your data, and encrypt or mask your data, so before ingestion, and does a preload and postload reconciliation. So all those is part of a loading engine. So then we have a data flow adapter, so which is primarily connecting your extraction and loading, basically which column from your source to be mapped into which column in the target system. So that's that sort of all mappings are done at the data flow level. And in addition to the mapping, it has all the active transformations like normalizer, joiner, unifier. So all those active transformations are taken care at the data flow level. Okay. Then we have unique components like migration flow for helping organization to migrate data from one system to another system, and then process flow for orchestrating their complex data integration scenarios. Then data exchange adapter to seamlessly pass the data from multiple systems as a service. Then we have scheduler to schedule your jobs, and for all the batch mode data integrations. Okay. So with that architecture overview, let's move on to the next one. Okay. So this is a list of connectors that we currently support. On the databases, we support all the major databases like Oracle, Postgres, SQL Server, SAP, HANA, MySQL. So all the major databases are supported. On the streaming part, we have support for Kafka systems. And the enterprise applications, you can see again all the major enterprise applications like Oracle Business Suite, SAP, JD Edwards, IBM Maximo, SAP S/4HANA, okay, and NoSQL, MongoDB, Amazon DynamoDB, Azure Cosmos, and then search engines like Solar and Elasticsearch. We have variety of all the cloud application support as well, okay. And on the big data lake space, Hive, Impala, Snowflake, Databricks, Redshift, Google BigQuery, Azure Synapse, and on the message broker side, IBM MQ and ActiveMQ. And pretty much in the enterprise storage systems, we have covered pretty much all the major systems like OneDrive to SharePoint, Box.com, Google Drive. And we have a generic API connectors like REST, SOAP, GraphQL, and OData for connecting any systems that supports these APIs. So in today's session, we are going to see three main processes like data ingestion, data integration, data migration. Okay, and data ingestion is the process of collecting raw data from different source systems and transferring to a centralized repository like database, data warehouse, or data lake. And basically, it moves data from source to target without any modifications or transformations. Generally, it doesn't verify any conditions or data quality issues. Okay. And in the data ingestion, there are two types like batch mode and streaming. In the batch mode, data is collected and transferred in batches at regular intervals. Basically, data is collected and scheduled to run in a particular interval. Okay. And streaming, so data is collected in real time or in real time and loaded to the target system immediately. Then data integration is the process of combining data from multiple source systems to create unified sets of information for enabling businesses to make data informed decisions. Okay, so the process of data integration, so it starts with ingesting raw data and then transforming the data, then loading the transformed data into the target systems. And integration as well, we have two modes like batch mode and real time. And the batch mode, data is extracted and clients transformed and loaded into the target system in real time. Data is collected in real time and loaded into the target system immediately. Then the data migration. So data migration is the process of transferring data from one system to another system. Basically, it's one-time migration from one system to another system. So. And the reasons for most common reasons for data migration is like application migration or upgrades, like companies may use one application currently and they wanted to switch from one application to another application, or they wanted to upgrade their application from on-premise to cloud, or else they want to replace or upgrade their storage systems, and database migration. They may want to move from one database to another database, or like company mergers and acquisitions. So in this case, like when the companies are acquired, like they may use different applications, and the companies wanted to have one common system for all the companies acquired. So in those cases also the data migration is comes to picture. And then cloud migration. So in the cloud migration, either storage or database or application, basically from on-premise to cloud, the companies wanted to move. So that in those cases also the data migration comes to picture. Okay, now let's get into the system. Hope you're able to see my screen. So this is a homepage of dataZap system. So all the menus are listed here. And if you want to switch to another application within the Genesis platform, here you go. Like all other applications like dataZen for master data management and Zen's app builder and SmartBots. So all those systems, you can switch between these systems. Okay, so in dataZap, all the configuration starts with sprint definition. Okay, so sprint is nothing but which test cycle you are going to do. So basically, by using one system, you'll be able to run multiple test cycles. So that's the power of the sprint definition in the dataZap. Okay, and then next one is like need to configure connections. So whatever like to move data from one system to another system, first the configuration you need to do is defining your source connection and target connection. So by using this connection only, the dataZap is going to extract the data from the source systems and load data into the target systems. So first we are going to see data ingestion. So how can we build a data ingestion, a simple data ingestion using dataZap? So the example we are going to take is we are going to extract data from Oracle E-Business Suite and to load those data into a Snowflake system. So that's the example we are going to take. Okay. Let's see the connection definition. So this is the EBS connection definition forms. So this is the connection we are going to use for extracting the data. So I have already configured this connection. Okay. So to connect to the EBS system, we are going to use JDBC in the backend and its Oracle database. So we're going to connect to the Oracle database by using its SID and just simple username and password based connectivity only. Okay. And this is our source. And our target is going to be the Snowflake. Let me show you the Snowflake connection as well. Okay, so here you can see all the big data connectors. Go to Snowflake. So this is a Snowflake connection. So we are going to use as a target system. So in the database information, you can see so the authentication types like DB user credential and OAuth2. So currently in this connection, we have used a DB user credential and which variables we are going to connect and what's the account URL and what's the staging it's going to be and database name and schema name and username and passwords are defined here. Okay. So now what we have seen is we have saw two connections. One is EBS connection, which is our source system for this example. Okay. And then Snowflake connection is going to be a target. Okay. Now we can get started defining the extraction part. Okay. So to start extracting data from the source system, so we are going to create a data object. So data object is the one which is going to extract, which is going to help us to extract data from the source systems. So I need to select the connection to which I'm going to create the data object. Okay. Have selected the connection. So, and in the first page, all the generic informations are collected, like what's your data object name and what's the versioning for that data object and what type of object it is going to be. Like, are you going to use query-based extraction or you're going to extract data from the table or weave synonym, okay? And then like whether we are going to stage the data or not, and what's the sync option, and what's the data sync mode. So we are going to use a full refresh mode and we have incremental mode as well. Okay. So basically in the incremental mode is to extract the data incrementally, like for example, all your delta changes. So when I choose incremental extraction, only the delta changes will be extracted in every execution. Okay. So let me define the name for my data object. So AP invoice is the object I'm going to extract from EBS. I'm going to use a query mode. Save this form. Few more fields are to be selected. Yes, alias name. Okay, now the data object has been, the basic informations are given and created. The next step is to give the source definition. So the source definition, since we have selected the query option in the first page, here you'll be able to see the text area to enter the SQL query, what you are going to use for this extraction. So this is a query I'm going to use for extracting AP invoice data from Oracle e-business suite. So once I enter the query, what I need to do is I need to parse the query. So what happens while I parse the query is, so we'll parse the query and collect a list of columns from the query. So parse is successful. Here you can see all the columns from the queries. So it has too many columns. Okay. Just save. You're done. So this is enough to extract data from a source system. So after save, I need to compile this data object. So while compiling, what happens is the system validates and checks all the connections are tested, and all the queries, whatever I have given here, will be validated. Okay, so that's the thing is done while compiling it. So what else we have in the data object? So this is a basic data object we have created now. So just with the query, okay, and then we have like preprocessors and successors and filters also possible. Okay, since it's a query based one, so all the filters are taken care within the query itself. Okay, and preprocessor is a step by where you can define any SQLs or any other data objects to run as a pre-step. Say, for example, I have given a AP invoice query in the source definition. Okay, so before running that query, if I wanted to do any SQL to be executed as a prerequisite, that can be possible with the help of preprocessor. And there are two options here. You can just run any SQL query, or you can call a SQL function or a store procedure as well. Okay. Okay, that's it. So we have defined the data object. Now let's go to the loader. So in the workbench, you can see all the most commonly used objects. So you don't need to go to the menus each and every time. So in the workbench, you'll be able to navigate between these objects easily. So as we saw, so the loaders are the objects which are going to useful for loading the data into the target system. So the data objects are going to help you to extract data from the source system, whereas the loaders are going to help loading the data into the target system. So I'm creating a new loader. So Snowflake is my target system. So this is the connection for which I'm going to create the loader. Just click the plus icon. So this is also the loader also has multiple steps in it. Okay, so the first step starts with the basic informations like the name for the loader and version name, and whether you want to stage the data or not, and all other executions options are available. Like, do you want to pass this execution after data modeling or pre-validation, and like if you want to enable data profiling for this execution or not, and if you want to run this pre-validations. Okay, all the options are available here. Maybe let me define the Snowflake AP invoice. So I'm going to load data into a table in Snowflake. So I have. So with the basic information center, I'm going to save this. Save. So once I saved, on the left, you can see all the steps are visible now. So there are multiple steps in the loader. Okay. So for a basic loader to create, so the just step 1 and 2 is enough. Let's go to the step number 2. So here what we are going to define is the table name in which we are going to load the data. Maybe let me show you in the Snowflake also. Yes. So this is a Snowflake editor. So this is the table in which I'm going to load the data. Okay. I have already few records, like around 74 records already there. So to add a table, just type the table and pop up. Here you will be able to see all the table names which are matching to the ones. I'm selecting the first one. So once I select the table, what happens is the system parses the table and collects all the columns from that table. Okay, and it will show you which operation you are going to choose. So there are multiple operations here, like update, insert, update, upsert, and bulk insert. Since it's a big data system, generally bulk insert option is the one most commonly used. Okay, and on the right you can see all the columns from the table. Okay, so I'm going to select all the columns. And in addition to the columns list, you can see what's a delimited and separator enclosed by characters are shown here. So what do we need to fill in this? Like, so these are all comes with some default values. Okay. What happens is since it's a big data system, so whatever data that we are going to insert into the Snowflake, so all those data will be converted as a CSV file initially, and then that will be moved into the Snowflake system. So for creating the CSV file, so we are going to have this columns like what's my delimiter and what's my separator and what's the enclosed by character. All those informations are available here. Okay, so I have selected all the columns. I'm going to create a data set. So I add all the columns to this data sets. Done. So compile the loader. The loader has been compiled. Okay. So this is a very basic steps in configuring a loader. Okay. So this is so just for moving data from one system to another system, this configuration is enough. Okay. But if you want to know all the advanced options, there are multiple options are available. Like so the data sets that just we created, right? So in this example, we are going to have only one data set since it's a kind of a database system. For application-based ones, you'll be having multiple data sets within a loader. For example, if you're going to create a customer in a Oracle Cloud or SAP systems, so in those cases, a customer object will have multiple sub-objects like a customer location and sites. So all those are considered as a data set within the same loader. Okay. And attributes are nothing but all the columns, whatever we have selected here will get converted as an attribute for this loader. Here you can see. Okay. And then if you want to define any unique constraint in this loader, you can define. So what happens is it's not, you may have a constraint in your target loader, okay, but in addition to that, if you want to validate any additional uniqueness, then you'll be able to define it in the system loader itself. And then there's a preprocessor step. So preprocessor step is the one which is going to run just before loading the data. Okay. Again, here there are multiple options. You can run any SQL query or procedure or function, or you can call another data object to execute just before loading the data. Then we have a transformation. So like lookup transformation and sequence and expression, data masking. So all those transformations are available here. So lookup is just like if you want to look up any data against your system. Say, for example, it's most commonly used in application to application data movement. For example, from my source system, I'll be receiving only the unit of measure code, but my target system is looking for UOM ID. So in those cases, what the use of lookup transformation is to do a lookup and get the corresponding UOM ID for the given UOM code. So that's a use of lookup transformation. Then we have a sequence transformation to create a running sequence numbers, like if you want to assign some unique IDs to a attribute, so that you can achieve with the help of sequence transformation. Then we have an expression, like if you want to concatenate two attributes into one, or do a substring of one column. So all those transformations are supported with the help of expression transformation. And then you can mask your data. Say, for example, in the masking, there are multiple options available. Okay. And you need to define the multiple masking formats also. So data masking is a feature which helps you to mask your sensitive data in the system. So that's a use of data masking. And then we have an option called pre-validation. So it's again another unique feature of our system. Okay, so pre-validation is the one which is going to validate your data, so whether it meets all your target systems requirements. So for example, when you migrate your item master data from one system to another system, okay, so the given values in the item master, like UOM code or warehouse or organization or item type, so all those are valid values or not. You don't need to wait until the target system throws an error. Okay, so you can add a validation here, and which is going to help you to validate your data before loading the data into the target system. So that's the power of pre-validation. And one more thing is, like if you don't validate your data, what happens is the target, your data will be rejected by the target system, and there can be multiple errors in a single row. What happens is, like but the target system will not give you all the errors in one shot. Okay, so you need to correct your errors one at a time. Say, for example, when you move item master data, if your UOM code is invalid, then you will get to know only the UOM errors at a time. And then, but the same row may have a error in the item type as well. So that you will not be able to know until you process the same data again. Okay. But the power of pre-validation is, what it does is it validates all the checks in single shot. And when you execute the data, you'll be able to know all the errors in a single row. Okay. And then we have a reconciliation engine. So there are two types in the reconciliation you can do in the loader itself. They're like preload and postload. So preload is the one that reconciles your raw data and the transform data, just in case. So these are all most commonly used in the data migration scenarios. Like before I move the data, I wanted to know what's the change has been done in the form of transformation to my data. Okay, so it will give you the comparison results between your raw data and the transformed data. And then similarly, we have another option called post-load reconciliation. So in the post-load reconciliation, what you'll be able to see is it's going to reconcile the transformed data with the actual data that got loaded to the target system. Okay, so the preload is the step which is going to run before loading the data, whereas the post-load reconciliation step is going to run after the data gets loaded into the target system. Okay, so that's the difference. And then we have a cross-reference mapping. So for example, I'm moving invoice data from one system to another system, and the invoice number in the target system is going to be different. So I want to create a cross-reference between the source system's invoice number and the target system's invoice number. Or So in such cases, the cross-reference mapping will be really helpful for you to build a cross-reference. And then we have a post-processor step, which is going to so we have a preprocessor. We saw a preprocessor, right? So similar to that, preprocessor is a step which will run before loading the data, whereas the post-processor step is the one which is going to run after loading the data. Okay. So again, here you can run any SQL query, or else there's another option called source update. For example, when I move data from one system to another system, okay, I wanted to know whether my data got loaded into the target system successfully or not. If it is any error, I want to know those errors and its status in my source system itself. Say, for example, I'm moving data from one table to another application. Okay. But once I move the data, I want to know its status in my source table itself in a one particular column. So in those cases, the source update option will be really helpful for those cases. Okay. So here we have multiple options, like whether you want to have success and error both, or only error. So it's up to you to choose which one you want to go with. And then the next one is approval. So it's again most commonly used in the data migration scenarios. Okay. So we have a data marting available in the loader. So once what we do is once we collect the data from the sources, the data gets stored in the data mart, and then the data gets pre-validated and transformed. All those transformations are done at the data marting level. Okay. Just in case, if you want to have a business user to verify the data after data marting or before data loading, you'll be able to set an approval. And in the approval, there are multiple options like a single, hierarchical, parallel. So all the multiple types of approvals are available. Okay. So when you set an approval, what happens is the user who is going to execute this job may be a different person, maybe a support person. Okay. But in your organization, you may want the business users to verify the data before the data gets moved into the new system. Okay. In those cases, the approval process will be really helpful. Okay. So we have covered all the loader steps in detail. Okay. And so as we saw earlier, only the first two steps are mandatory or very basic steps. Okay. So for loading data into the target system. So rest all are optional. If needed, based on your use case and requirements, you can define it. Okay. So with that, now let's move on to the next step. So let's quickly summarize what we have done so far. We have saw the connection steps for source and target. The source is Oracle Business Suite, and the target is going to be a Snowflake. Okay. So we saw the connection configurations, what we have done. Okay. And then we have created a data object to extract data from the source system, which is in this example is Oracle Business Suite. And we have created a loader, which is going to load data into the Snowflake. Okay. So now we have the data object to extract ready, and the loader to load data into the target system. It's also ready. Okay. So in the data ingestion, to do a data ingestion, the next step is to create a data flow. So the first step we did is we created a data object, and then we have created a loader, and now we are going to create a data flow. So I'm clicking the plus icon, choose a sprint in which I'm going to choose the dev sprint, and I need to choose a data mart. Okay, once done, enter a name for this data flow. One EBS Snowflake AP invoice. And you can see the loader execution type parallel and serial. It's advanced configuration. Like this may be helpful when you have multiple target systems to be configured within a single data flow. So in those cases, you can define whether all my loading to run in parallel or serial. So that's a option here. You can see. Let's save this configuration basic. And the next step is yes. So this is the data flow designer window where we are going to define a data flow. So data flow is nothing but it's a data pipeline which is going to extract data from one system and move that data into the another system. So that's a main use of data flow. And here you can see source, target, and then all the passive transformations are listed here. Let's see this, define the source. So I already created a data object. So in the source, there are multiple options. Let's for this example, we are going to use the data object. Okay. So this is the data object I created. We connect one EBS SAP invoice, select it. And then, so my source is added here. And now I'm going to add my target. So the target is I already created a loader, which we saw, right? So okay. So now we have the source object, which is data object, which is extracting data from the Oracle Business Suite, and we have the loader, which is going to load data into the Snowflake. Now we need to connect these two. Okay, connect these two in the sense like you can simply drag and drop. A line is formed. Okay, so this is the mapper which is going to define which column from my source to be mapped into which column in my target. So that's a use of mapper. I open the mapper. So in the mapper, what it will show is all the columns from your source. Okay, so these are the columns I have in my source query. Okay, and these are the columns I have in my target. So I have chosen the map by name exact match. So by doing exact match, what I'm doing is what are the columns are common between the source and target will get mapped automatically. Like this, yes. So here you can see, I just click this button. So all the columns between so which are common between the source and target got mapped automatically. Okay. Now, so in the target, still I have 5 more columns to be mapped. Okay. For that, there are the columns are not matching exactly. So that's why it's not got mapped. Now we'll map it manually. Okay. So in the source, it's the column name is invoice underscore num, but in my target, it's the invoice number. So you select these two and add, it got mapped. Okay. And similarly, I'm going to vendor site code to the vendor site name. And then invoice. Invoice type, lookup code to invoice type. And then what payment method code is going to be mapped to payment terms. And then payment currency code is going to be mapped to the currency. Done. Okay. So now I have mapped all the target columns, but still I have few more columns available in the source. So for example, here you can see like in my source, I have 225 columns. Here you can see the count. Okay. But in the target, I have only 15 columns. Okay. So I have mapped all the required columns for my target. So I can leave the remaining columns as is. So I have completed the mapping. I'm going to save this mapper. And save the data flow. And compile it. Done. So now the object to do a basic ingestion, data ingestion is ready. Okay, so if I run this data flow, what happens is it's going to trigger this data object, which is going to extract data from the source, which is e-business suite. Okay, and then it will pass the data to the mapper, and mapper will do the mapping, and based on the mapping, it's going to send the data into the loader. Okay, which will load data into the Snowflake system. So this is a basic. So one data flow is required to do a data ingestion. So I have very few records configured just to make sure for this demonstration. Okay, so let me run this data flow. Okay, so the extraction has completed. It has extracted 13 records from the sources. You can see the count here as well. Okay, and loader also got completed. It got all the 13 records got loaded into the target system. If you want to see in detail, like what all the records got loaded, you can just click on this loader. It will navigate you to the loader summary. So this is the loader summary. Here you can see what's your source and what's your target, okay, and how many records got processed. So if there is an error, those errors will be listed in the right side chart. If you want to see the data, just click on this count. You can see all the data. If you want to download this data, so we have multiple options like which data set you want to download. So in our case, we have only one data set. So if you want to download, you can download. Okay. So go back to the data flow execution. Okay. So quick recap. So we have completed a data ingestion configuration, and we did one simple data ingestion. Okay. So for that, what we have done is we saw a connection configuration, like one for source and another for target, and then we created a data object to extract data from the source, which is on the left side. Okay, and then we created a loader to load data into the target system, which is on the right, and then we created a data flow to form a data pipeline. Okay, so it's done. So whatever we have saw is a simple data flow. Okay, and there are a few more. If you have any complex scenarios, like I want to transform my data before loading the data into the target system. So all those transformations are here. You can see joiner, normalizer. So joiner is basically the one which is going to join multiple entities into one. So for example, in my source, I have, I'm receiving it as two entities or two files. Say for example, I receive two files as an input, but my target system, it's going to be just one single table. In the cases, I use the joiner transformation to join all the data, okay, and make it to one and move the data into the target system. Similarly, the normalizer transformation is going to be helpful to split the data. Say, for example, in this case, like my source system is providing one file as an input file, but whereas in my target system, it's going to be two different tables, or else it can be like two different target systems. It's that's also possible. Okay, so in those cases, you'll be able to split your data by using the normalizer transformation and then pass it. Okay, and in addition to that, we have few more passive transformations are available, active transformations are available, like router. Router is basically used to route your data based on the conditional logics into multiple systems, and sorter is used to sort your data, and then have the aggregator to do some aggregated calculations like sum, count, or min, max, and arrive the values. And comparator is a unique transformation that dataZap provides, which is really helpful in the setup migration scenarios. Like if you want to, if you have already system, okay, say for example, either SAP or Oracle Cloud, okay. So in those systems, if you want to do a setup migration, like from one organization to another organization, or like one OU to another OU, so in those cases, The comparator will be really helpful to compare what are the setups that already exist in your target OU, and you can compare and do the mappings. And unifier is the one basically just in database terms, what you do with the union and union all. So that's one the unified transformation does. And passive transformations like lookup, sequence, expression, data masking. So all those are done with the passive transformation. Okay, so as we saw, so this is a simple data ingestion or data flow. Okay, and if you want to see one complex one, let me show you one complex one as well. Okay, so here you can see, and the one which we created is a one-to-one. Like, so I have one source and one target, and I mapped it without any transformation. Okay, it's a one-to-one data ingestion. Whereas in this data flow, you can see multiple sources available on the left, and similarly on the right, you can see multiple target systems. Okay, basically what we have done is like we have collected a file from Amazon S3 and OneDrive, and then clubbed it together by using the unified transformation, and then that data is being passed to a router for splitting data based on the conditional logics. Okay, and then based on the conditional logic, it's been passed to different target systems. On the right, you can see multiple target systems like loaders are available for Databricks. So one is loading data into Databricks, and another is loading data into Oracle. And the third one loads data into Snowflake system. And the fourth one loads data into the Postgres system. Okay, so this is another example for for a complex data flow. So the one which we created is a one-to-one, whereas here what we are seeing is the it's a many-to-many, because my source is multiple sources and target is also multiple. So it's we can say it's a many-to-many data ingestion or data movement. Okay, so we have covered the data ingestion part. Next, we'll move on to the data migration. So to do a data migration, we have a unique object called data migration flow. So which is primarily used for doing all the data migrations, primarily used for application upgrades or application to application migrations. Okay. So in the migration flow, what we do is we saw a data flow, right? So let me show you once again. So this is one data flow. So meaning it's moving data one AP invoice objects data alone. It gets moved from one system to another system. Okay. Similarly, in a data migration scenario, you may have a bunch of objects. Say for example, if you are moving your data from Oracle e-business to Oracle Cloud, okay, there can be a huge number of objects to be migrated from one system to another system. So in those cases, what it's going to be look like is we are going to create one data flow per object. So for example, if I'm going to do data migration for procure to pay module, okay, just example, okay, then you need a supplier side, purchase requisition, purchase orders. So for each of these objects, you'll create one data flow. Okay, and then in the migration flow, what we are going to do is we are going to combine all those data flows in one single migration flow. I'll show you how we are going to do it. So for this demonstration purpose, I have already created all the required data flows. Okay, now I'm going to just create a migration flow alone. The example I'm going to take is it's application to application migration scenario. Okay, so where my source application is Oracle e-business suite and my target application is Oracle Cloud. Okay, so basically I'm my organization is moving from on-premise application to a cloud application. So I have chosen a sprint and I need to give a name for this migration flow. It's EBS2 Oracle Cloud. And I'm going to configure this migration for two modules, procure to pay and order to cash. Okay. And here you can see multiple configuration options like parallel extraction. So parallel extraction is nothing but once we configure all the objects here, so find it later. And then we have a status indicators. So there are three options like in the status indicators like green, amber, and red. So what does it mean is so in my data migration, if my data in my data migration, if the success percentage is above some defined percentages, I wanted to mark it as green. Okay, so for example, let me key in like 90%. Okay, so if my in the data migration, if my success rate is 90% and above, it will be marked as green. Okay, and then if it is above 70%, then it will be marked as amber, and below 70%, anything will be marked as red. Okay, it's just a status indicator. You can have your own definitions as per your organization's need. Okay, so I have given basic information, and then I need to create a group name. Okay, so as I said, I'm going to create two groups. One is procure to pay. Just added it. Okay, I need to add at least one data flow to this group to save the migration flow. Okay, so I have created a migration flow, and then I have added a group called procure to pay. So basically, in application to application migration scenario, it's all going to be a modules are going to be your group names. Okay, within each group, you are going to have multiple data flows. So the procure to pay starts with supplier master. So on the left, you can see all the data flows. So these are all already pre-configured templates. Okay. So I have added the supplier master. First, I'll save this migration flow and then add the remaining ones. Okay, done. So I have added the supplier master as one step, and then the next is going to be my supplier address. Okay, so when I run this migration flow, what's going to happen is all the data flows, whatever I added here, will get executed either in serial or parallel based on the configuration. Okay, so in the procure to pay cycle, it's going to be sequentially order. Okay, so after supplier master, I'm going to define supplier address, and then after supplier address, I'm going to add supplier site, and then supplier site assignment, then purchase order requisition, purchase orders. Save it. Okay. I add purchase order next to the purchase order requisition. And then the next one is purchase order receipt. And then the next is going to be AP invoice. Then invoice payments. And then GL balance. Okay, so let's save the migration flow. So I have, so Not all the objects I have included here. Okay, so just for example, I have added the procure to pay module, and in the procure to pay module, all the sequential objects like these are all dependencies. Say for example, to create supplier address, you need a supplier master first, and then you need to create a supplier site, you need a supplier address. So these all these data migration, basically the application to application has to go in this order. First, to move procure to pay module from one application to another application, this is the order, like first the supplier master, and then supplier address, and supplier site assignment, then purchase requisition, and then purchase order receipts, AP invoice, so invoice payment, and GL balance. So this is the order. Okay, and then so this is procure to pay. Now I'm going to add one more group in the migration flow, which is order to cash. Okay, so in the order to cash, I'm going to add the relevant data flows, like okay, so the order to flow starts with customer, added customer, and then I have a price list. So it's a common price list. It's not a customer based price list. It's a common price list. So that's why I added it as independent one. And then I'm going to add a sales order. Okay, so my sales order is going to be dependent on customer, and I need a price list also for moving the sales order. So basically what the thing is, for sales order, both the customer and price list, both are dependent. Okay, so then what I do is I again drag the sales order and drop it over the price list. Now the new line is formed. So what does it tell is, so the customer and price list will run in parallel. Okay, once these two completes, the next step, the sales order will get started. Next, I add AR invoice. Next, I add AR cash receipts. See. So this is how migration flow will look like. So what we are doing is, again, we'll recap, like we are doing an application to application migration. The source application is Oracle E-Business Suite, and the target is Oracle Cloud. Okay, and in the example we have taken is we are moving procure to pay and order to cash module objects. Okay, so this is how it's going to be look like. So when I run this, I compile this migration flow. When I run this migration flow, what is going to happen is it's going to start all the it's going to trigger all the data flows which we have defined within this migration flow one by one. For example, there are two groups within this migration flow. One is procure to pay and order to cash. So these two will get started in parallel. So there is no dependency in between these two groups. Okay. If you want to have any dependency to be added among the groups, that's also possible. We have the option called add dependencies. So by using this add dependencies, we can add the dependencies. Okay. So so since there is no dependency here, so these two groups will get started in parallel, and within the order to cash, the customer and price list will start in parallel. Once these two completed, the sales order will get started, and then AR invoice and AR cash receipts. And in the procure to pay case, everything is sequential. So first the supplier master will start, then supplier address, and then supplier sites, like that the flow goes. Okay. So when I execute this migration, it's going to take a long time. So I'm going to show how the execution result will look like when I execute a migration flow. I go to the execution history. So this is how the execution result will look like. So we defined some status indicators, right? Green, amber, red. Okay, here you can see. So the objects which has success rate more than 80% are marked as under green bucket, and there are no objects under the amber bucket. Okay, there are 2 objects under red. So if you want to see only red, then just you can check this. Here you can go. So these 2 objects has more errors in the sense like 0 success rates. Okay, so all the records, whatever we processed is fall into error. Okay, and if you see these ones, here you can see the success rate is more than 80%. Okay, if you want to see the errors, you can just click on the error count. You'll be able to see the error records. And to correct the errors and reprocess, we have options like if you want to reprocess the data flow or rerun the data flow. Okay, so what does it does is reprocess in the sense like you can correct the errors online in the grid itself and then proceed for reprocess again. And rerun means if you want to fix the errors in your source system and re-extract the data, then the rerun data flow option will be helpful. Okay, so by using migration flow, basically what we are going to achieve is one single migration flow will be able to handle a complex data migration. Like you can define hundreds of objects in a one single migration flow. You can define in which order it has to go, and all the dependencies you can define between the objects. So that's it. Like so senior management also can come in and see where is your data migration in currently in a cutover period. So this migration to execution summary will give you a quick summary, like how many objects are in green and how many objects are in amber and how many objects are in red. Okay, so it will give you a big picture. Okay, so now we have covered the data migration and data ingestion part. Now let's quickly see how the data integration works in dataZap. So let's complete the batch mode one. So for batch mode integrations, how it works is we have our own scheduling engine. Here you can see the scheduler. By using the scheduling engine, we'll be able to configure the batch mode integrations or ingestions. Okay, so here you can see what are the objects you can schedule. So you can schedule a data object, you can schedule a data flow, you can schedule a process flow. Process flow, we are going to see it in the next topic. Okay, and data flow, if you want to run a data flow in a scheduled interval time, just click on this plus icon here. Enter a name for your scheduler. Okay, and select the data flow which you are going to schedule. The dev sprint. Okay, so this is the data flow I'm going to schedule. Okay, the one which we have created recently. And on the right, you can see the scheduler details, like whether you want to run it only once or recurringly. So if you want to recurring, like to run it automatically at a scheduled interval, then you can go for it. So when to start, can give the start date, and then interval, like you want to run it minutely in the sense like I want to run this job every 5 minutes and 24/7, or during only working hours only, or during non-working hours only. So all those options are available. And in the hourly option, you can define like every 2 hours, and again 24/7 or during working hours, non-working hours. Then we have the daily option, every 1 day or 2 day, and run on only working days. You can define additional timings as well, like I want to run this job daily, morning 8 a.m. and evening 9 p.m. So all those configurations are possible. And then you can have an option like a weekly, like I want to run it on Mondays and Wednesday alone. That's also possible. Or else you can go for a monthly option, like first day of the month or first working day of the month. So all those options are available. So by using this scheduling engine, you'll be able to manage your batch mode data ingestions and data integrations. Okay. Now let's say quickly see the real-time data integration. So for real-time integration, what we need is like we need to publish our objects. So whatever data flow that we create here, okay. So the example we are going to see is we are going to see a real-time integration between Procore and Impala, which is a big database. Okay. So in the Procore, what we have is Procore is basically, so this is a Procore application. So it is a project management software for construction-based companies. So that's all about Procore. Okay. And they have support for webhooks. Okay. Webhook is nothing but a you'll be able to trigger an event-based triggering, like this is a webhook configuration in the Procore system. Okay, so these are the objects they have, like you can see all the objects are listed here. So for example, here you can see the columns like create, update, and delete. So if you want to, on this, if you want to trigger a webhook for the events, like create event or update event. So for example, I'm going to define create and update event for change events, and then cost code. Okay. So for these two events, I wanted to trigger a webhook. So webhook is nothing but I have given my REST API URL here. Okay. So this REST API will be triggered by the Procore system whenever a new entry is added in the two objects that I selected, like change events and cost codes. Okay. Change events and cost codes. Okay. So to do this, what we are going to do is so we have set up maybe let's assume that we have already published our object and configured here. Okay. I'll show you how we are going to publish our objects as a API. Okay. And one more thing is like, so this is the request payload which I'm going to get from the Procore system. Okay, so project ID and resource name. Resource name is nothing but the objects which we have selected, like change events and cost codes, right? And the event type, whether it's a create event or update event, and the resource ID. Resource ID in the sense like which if I have created a change event, and the unique ID of that change event will be passed as a resource ID. So this is the payload information that the Procore is going to give as soon as a new entry is added in the change event or cost code. Okay. And in our system, what we are going to do is, so we have a process flow. Process flow is primarily used for orchestrating your data integrations. So we have see migration flow. So migration flow is used for data migration, and the process flow object is going to be helpful for data integration scenarios. So process flow is basically a workflow engine. Okay, so which is helpful for you to, so there are, you can see on the right, you can see multiple activities and constructs are available, like constructs and do while loops for each. Okay, and using the parallelize option, you'll be able to run jobs in parallel or sequential, and while loops to iterate the data. Okay, and on the activity side, you can call any data flows. So we have created, okay, and data object, you can configure email notification, or you can call a MDM flow, or you can call a reconciliation process, or you can call a cell script, or a Spring integration call, a scoop job, or you can call another process flow as a sub process, or you can define a approval process here. Okay, so it's a completely a workflow engine, pretty much flexible enough to handle all your complex data integration needs. Okay, so in this process flow, what we are seeing here is like so in the webhook, what we are going to get is we have configured two objects like change events and cast codes. Okay, in the so for all those objects, only one AP will get triggered. Okay, only one AP in the sense like whether it's change event or cast code or any other object, only this REST AP will get called. Okay, and to handle the scenarios, like we have a different object to process the cast codes and a different data flow for change events. Okay, so when a new item is created in the Procore system, it will trigger this REST API, and which in turn is going to execute this process flow. Okay, so first I wanted to split like which object I'm receiving data for, like whether it's a change event or cast code. Okay, so for that, what we have done is we have created two variables. What type of objects it is? Change event object and cast code. Okay, two different variables, and then I have a if condition block where I check what is my resource name coming in as an input. So the resource name is nothing but this payload, whether I'm going to change event as an input or cast code. Okay, based on this conditional logic, two different data flows will get triggered. So that's the condition is all about. Okay, so if the incoming resource name is change events, then the change event data flow will be triggered. If the resource name is cast code, then the cast code relevant data flow will get triggered. Okay, I'll show you how we have published this process flow as a API. So to publish any of our objects as an API, we have a API gateway. So that's publisher. So to publish an object as an API, just go to this one. So here you can see what are the objects you want to publish as an API. Okay, so in our case, I'm going to choose process flow as a one. So just need to enter a name for the publisher and select a publisher name, process flow name here. Okay, and then just select the service type, whether you want to publish it as a SOAP service or a REST API. Okay, and then whether you want to run the call this option as a synchronous or asynchronous, and in which authentication mode you want to use. Then what's the input format is going to be the basically the request payload for this REST API, whether it's a JSON or XML. Okay, and similarly what output format you are looking for, like JSON or XML. Okay, once you just select the process flow and save it, you'll be able to publish it as an API. So it's really simple. Maybe let's quickly publish one process flow. So just some sample one. Okay, saved it. Okay, now go to the more options and publish. So once I click the publish, what happens is this object is going to be published as an API. Done. At the bottom, you can see what's my REST API URL, and you can download this sample request payload as well. So you can copy this link, so the REST API, and you can go to the Procore or any other system. So in our example, we have used the Procore system as the source for event-based triggering. You can use it like in a Salesforce or in any other application wherever you have the support for webhook systems. Okay, so this is how the near real-time integrations work. So maybe I quickly recap integration part. So we have a data flow, multiple data flows created. Okay, to orchestrate the multiple data flows to run in conditional logic based, we have created a process flow. Okay, and then what we did is we published that process flow as a REST API. Okay, so that REST API can be consumed from any third-party systems, whether it's Procore or Salesforce or any other systems. Okay, you will be able to trigger it. So whenever a new event is triggered in this application, this webhook REST API will get triggered. In turn, it's going to call our process flow, and it's going to run the corresponding data flow internally, basically based on the conditional logics. Okay, so what we have covered so far is in the first one we have covered data ingestion, like how we are moving data from Oracle Business Suite to Snowflake as a one example, and then we saw migration flow, how the dataZap easily handles the data migration, basically the application to application migration, and then we have covered the process flow for and the publisher, basically the API gateway, how we can publish our objects as an API for near real-time integration scenarios. Okay. I think we have covered almost all the topics we planned, and now it's a time for questions. If you have any questions, please share.
Okay, thank you so much for giving us this hands-on training. I learned a lot throughout the whole process. So let's go ahead to the questionnaire. The first question I have, or the audience has, what if a connection fails during an integration?
Okay, so for connection fails. Okay, so we saw the connections, right? So the connection is the one primarily used for connecting your sources and target systems. Okay, so during an integration or moving a data, what if a connection fails? So in the connection, so we have options like retry options available in the connection. That's configurable. Okay, like maybe your source or target may not be available for just at that moment. Okay, so in those cases, what happens is if you have given the retry option, whether 3 times I want to retry or 5 times, and how frequently or what's the interval time for each retry, so that's all available in the connection configuration. Okay, so if the first connection fails, then it will wait for example, I have given I want to retry 3 times, and at the interval of 10 seconds. Then what happens is when my connection fails for the first time, it waits for the 10 seconds and then do retry, and then again it fails, it waits for again 10 seconds, then retry. So these are the options available for handling the connection failures. Okay, and if still it doesn't work even after multiple retries, okay, the object will get failed, and we have notifications available in the objects, like if there is any failure, if you want to get notified, your admin person or support persons, you want to get notified, so you can configure the notification, and as soon as the any object gets failed, they will get an email notifications immediately.
I thank you for that. The next question, how does it handle a large volume of data for ingestion?
That's a good question. Like in the data ingestion, whatever we saw is a very small data. Okay, how we handle a huge volume of data. So we have there are some governor limitation at the target system side. Okay, say for example, if you are loading huge volume of data into Snowflake or Databricks, and during the bulk insert mode, you need to split your data into multiple chunks and then load into the target system. So that's the expectation. Okay. So what we do is we have customized the governor limit at our end in the connections and loader. Okay. So where you can define, like say for example, I'm receiving a few millions of records from my source system. Okay. And then we need to split those data into multiple batches. Okay. And for each batch, what is the record limit, or what's the file size limit, or all those configurations are available. You'll be able to define your batch sizes. And so once you define your batch sizes based on your target system's requirement, then it's all done. Like whatever volume that you are going to receive from your sources, dataZap is going to take care of for you to split those data into multiple batches and keep sending into the target system in parallel. Okay, so for that also we have multiple options, like once we split the data into multiple batches, okay, you can keep processing each batch one at a time, or in parallel also. So that's how we handle a large volume of data in the basically at the time of ingestion.
Okay, thank you. The next question is it possible to hide sensitive data without exposing its value while processing?
Yes, definitely possible. Maybe in the example also we saw data masking in the transformation. Okay, so there are two options to hide the sensitive data in the dataZap. One is you can encrypt your data completely, okay, or you can mask your data. Okay, so the difference is like for example, I'm processing HRMS data, some sensitive salary information, or your SSN information are coming to the middleware. Okay, and I don't want anyone who is processing the data in dataZap, so those persons should not see those sensitive informations. Okay, so in the examples we have so like you can see the error records and success records right in the grid. Okay, so if you don't enable encryption or data masking, all those informations are visible in the grids. Okay, if you have enabled encryption for sensitive data or masking, then those data will be completely masked or encrypted in the grids, so nobody able to see that in the system. Okay, that's one thing. And another thing is, you may have a requirement like in the target system, I don't want to move the actual data which are sensitive. Okay, I want to mask it and then load. So then you can go for the data masking transformation. So what it does is it masks your data and then push into the target system. And another thing is you can encrypt your data and load into the target system. So both options are available by which you'll be able to handle this requirement. Thank you.
Okay, I think we have 1 more minute for one last question. Is there any option to profile the data?
Profile the data, yes. So so this changes platform is not just ETL or integration platform for your needs. So it has it has all the data needs can be handled by the changes platform. Okay, so for profiling we have two options. You can do it as a prerequisite step for before move your data as a separate process to profile your data and get all the insights of your data as a separate process. That's also available. Or else you can do it on the fly as well, like when I'm moving data from one system to another system. So during moving the data itself, basically at the time of data migration, I want to profile and get its insights. That's also available. So there are two ways it can be handled.
Okay, thank you. Well, thank you so much for presenting and training us on dataZap. I learned a lot. I don't know about the rest of the audience. Thank you to the audience for joining us tonight. I know it's a bit late. So I hope you guys enjoy the rest of your night, and I hope to see most of you guys tomorrow.
Thank you everyone for joining with us today. Thank you so much.